bottom where it says real numbers. Okay, so real numbers are all the numbers that we study. Okay, we study real numbers. So all rational and irrational numbers. Or another definition that might make a little bit more sense to you right now is all numbers that can fit on a number line. So basically all the numbers that we study. So a number that's not a real number is called an imaginary number, and or a complex number. So no, that's a little bit different. An imaginary number is when you try to take the square root of a negative number. No, we'll get to Q. Imaginary or complex numbers are either I for imaginary, or C for complex, okay? And that's only when you take the square root of a negative number. Square root of a negative number, okay? Those are non-real numbers. If you take your calculator and you try to take the square root of a negative number, so let's take square root of -2, your calculator says non-real answer. It's a non-real number, okay? It's not real. We only study real numbers, okay?
So rational number is one that can be turned into
Well, yes, okay? So in this big chart here, real numbers is all numbers here. So this whole outline, everything inside here are real numbers. That's the real number system. That's the system we're going to study, the real numbers. Okay, so all of these numbers that we study are real numbers. So real numbers can either be classified as rational or irrational. Okay, so you notice there's a box for rational and a box for irrational. So what do you think let's start at rational numbers are? Anthony already said it. Think of the root of the word ratio. Ratio. So ratio, what's another word for ratio? Fraction. Yeah, fraction. So all numbers that can be written, so just because it can be written as a fraction doesn't mean it always looks like a fraction. So sometimes they're disguised. It can be written as a fraction, as A over B. Okay. So how do we spot if a decimal can be written as a fraction? Well, does anyone want to take a guess? If you have 0.3 repeating, can that be written as a fraction?
Yes.
Yeah, it's 1/3. So all repeating numbers or repeating decimals, I should say, can be written as fractions. Okay, how about just 0.2? Can 0.2 be written as a fraction?
Yeah.
Yeah, 2/10. So how do we explain that? Well, that's terminating. Yeah, it ends. Terminating like the Terminator. So terminating decimals can be written as a fraction. So like 0.2, 0.3 repeating. Okay, so that's how we, and so just if it's rational, it could also be an integer, whole number, or natural number. All those numbers are also rational. So also are natural, whole, or integers. Can you write -2 as a fraction? -2/1 you could write. You could write it as, so -2 can be written as a fraction. Just put it over 1. And there can't be a decimal in a fraction, right? Or you could write it as -4/2. Those are all the same things, right? That's still -2. So all natural whole numbers and integers are also rational. They all can be written. So that's why they're enclosed in this. They're swallowed inside. So you could see, like, rational numbers is this whole box. Inside that next is integers, then wholes, and then natural. Okay? So all This is like inside, so natural numbers inside a rational. That means that integers are automatically also rational numbers. They can be written as fractions. So what's irrational? You probably, irrational. Yeah, Zach? Like pi. Okay, like it's always the first example that comes to mind. So this little symbol, notice the symbol for rational is Q. The symbol for irrational is Q with a little line on top. That line means not Q. So if it's not rational, it's irrational. It's always going to be one or the other. One or the other. So an irrational cannot be written as a fraction. So it's basically opposite of irrational. So rationals are repeating, then irrationals are non-repeating. And if rationals are terminating, then irrationals are so non-repeating and never ending and non-terminating. Never ending. So like pi. Pi is a great example. Okay, non-repeating and non-terminating. It doesn't end and it doesn't repeat. Doesn't matter if there's a pattern. Pattern is not the same thing as a repeat. Right? For example, 0.121, 11211, 1112111. Okay, there's a pattern in there, but is it repeating? No, it's non-terminating, non-repeating. Yeah, non-repeating, non-terminating. Thank you. Okay, also, that's in this category are square roots or cube roots of non-perfect squares or perfect cubes. So square roots of non-perfect squares. And that's the same thing as cubed roots of non-perfect cubes. So like the square root of 2. If you type that into your calculator, square root of 2. Oops, not negative 2 this time. Okay, that's going to be, your calculator will only show 9 decimal places. But it actually keeps going. Okay, it's not going to show you all of them, because then it just never ends. And there's your life, and you die, and it's still going on past your life. Okay, because they don't end and they don't repeat. So this, it's only going to show you 9. Okay, square root of a non-perfect square, no repeat, non-ending. If you see 9 decimals on your calculator, assume that it's never ending. Okay. All right, so those are always the two. We either have rational or irrational. It can be written as a fraction or it can't. So let's look at the smaller sets of rational numbers. So the next smaller set of rational numbers, actually let's go back to the top. So the smallest set of all is natural numbers, the very smallest set. Do you know what a natural number is? The ones that don't wear makeup? Right, yeah, that's it, you're correct. The ones, the counting numbers. Yeah, natural, that's why they don't wear makeup. Okay. Natural numbers are counting numbers. You're correct, Rebecca. So counting numbers, 1, 2, 3. And will they include decimals? No, because they're counting numbers. So in fact, all of natural, whole, and integer have no decimals. They do not have decimals. So if you see a decimal right away, you know it's not going to be natural, whole, or an integer. And what's a whole number? Think of the word whole. No decimal.
It's a number that is a multiple of 1, I guess you could say.
Okay, I'm really being cheesy when I say whole. It includes 0. That's the whole. It includes the whole. So it's counting numbers including 0. That's the only difference between natural and whole. So whole is the next smallest group. It's only one number bigger than natural. Counting numbers including 0. So, no, like 2 would be a whole number. It's a counting number, right? It also would include 0 in the set. So starting at 0, 0 is a whole. It's not a natural number, but it is a whole number. 1 is a natural and a whole number. It's also rational. Right? Okay, so what are integers? Negative and positive whole numbers. Negative and positive whole numbers. And again, integers do not include decimals. A common mistake is a student will see negative 2.3, and just because it's negative, they think it's an integer. No, it's only positive and negative whole numbers. So, or you could, well, the reason why I say whole is because of the 0. Yeah. Negative and positive whole numbers. Okay, so if you're an integer, are you also a whole number? If you're an integer, are you also a whole number? Negative 2, is that whole? No, so not necessarily. However, if you're a whole number, are you automatically an integer?
Yes.
Yes. Right? If you're a whole, you're automatically an integer. If you're a natural, are you automatically an integer? Yes, you're also an integer. If you're an integer, are you automatically a natural? No, because these guys aren't natural. That's right. Okay, so there's our number system. It's all inside of here. So natural numbers, right, are the smallest set. So you can see these are enveloped. If you're a rational number, right, there's numbers that are rational that aren't integers or whole or natural. But if you're natural, you're automatically inside the rational numbers. All of these guys, integers, whole, and natural, are all rational. Okay? So rational and irrational together, all the numbers would make what? Real number, our real number system. The real number system. Yeah. Number soup. Okay, so let's move on to the next page. So we're going to classify some numbers using our symbols. So these are the symbols, right? I for integer, W for whole, N for natural. The only ones that are kind of weird are rational and irrational. The reason why they are the symbol Q, does anyone take a guess? Think about fractions or division. No, quotient, because of the quotient. Because it's a quotient, yeah. So Q stands for quotient because of that. Quotient, not quotient. Okay, so let's look at square root of 4. Can you take the square root of 4? Yeah, what does it equal? 2. Okay, so first set that 2 is in. It's a natural number. If it's a natural, it's automatically also a whole number. Is it an integer? Yeah. Is it a rational number? Can it be written as a fraction? Yes. All natural whole and integers are also rational. And all numbers, so it's either rational or irrational. All of these will have a Q or a Q naught. And then is it also real? Yes. R stands for real. Okay. Okay, 3. Is that any different than the last one? Is it a natural number? Yes. Is it a whole number? Is it an integer? Positive, negative, whole number? Yeah. Is it a rational number? Can it be written as a fraction? Yes. And is it real? Yeah, it's the exact same. Okay, let's look at the next guy. Okay, first of all, which 3 can we rule off right off the bat? Natural, whole, and integer. It's not a fraction. It's not a whole number, right? There's decimals. So right away, if there's decimals, those first 3, we go right to either rational or irrational. So we want to ask ourselves, can this be written as a fraction? Is there a repeat or does it end? Does it end and is there a repeat?
The dots count as a repeat.
No. The dots. It's talking. It just keeps going. So that would be irrational, right? Because it's non-repeating, non-terminating, and is it real? Yes. All rational and irrational numbers are repeating. So everything here, unless it's a square root of a negative. 3 over 5. Okay, right away, because it's a fraction, we can eliminate which 3 categories? The natural, whole, and integer. So is it rational?
Yes.
Yeah, by definition, it can be written as a fraction, and all rational are also real. Okay, next guy. Right away, we can eliminate natural, whole, integer. Is it rational? Can you write it as a fraction? Yeah, it's shown that way, and then real. Okay, next guy. Square root of a negative 100. Yes. The only way a fraction can be natural, whole, or integer if it actually reduces to that. So like 4 over 2, it actually is 2. Yes. It is. Yeah, you can either call it complex or imaginary. So you could use the symbol I or C for complex. I means imaginary. I have a shirt I need to wear. It looks like this. It's got the symbol I, and then it says, I should wear it one of these days, keep it real. Yeah, I'll wear it one of these days. It's pretty cheesy.
I saw this little comic, it's like I says to I, please be rational, and then I says back,
Get real. Yeah, they're so funny. Okay, I'm going to show you a lot of those jokes this student. Okay, root 8. So we plug it in. So that's not a perfect square. Therefore, what would it be? Irrational. It's irrational. That's a Q with a line over top. Okay, it's irrational. Cannot be written as a fraction and it's real. All right, guys. 0. What's the first set that 0 belongs to? Whole. And then it's also an integer. So all whole numbers are also integers. And then it's also all no, that's if 0 is on the denominator. You can make it a 0 over 1. So it's also, forget rational. All whole numbers are also rational. And it's real. Okay, pi is probably the easiest one. Irrational and real, right? Cannot be written as a fraction, non-terminating, non-repeating.
It can't be everything because
Cannot be everything. Exactly. Okay, negative 3.75. So right away, did you guys want to finish these off yourself? And no? Okay, keep going together. Okay. So can it be the first 3?
no.
It's a decimal, so no. No decimals in the first 3. So next question is, can this be written as a fraction?
Yes.
Yes. It's a terminating. It's terminating. So if it terminates, it ends. Oops, no line on top. It's rational and real. All right, do you guys know how to type in cube root of 27 on your calculator?
Yes.
You do?
Using the math key.
Math key, so push math. Number 4. Number 4, so cubic root of 27 is 3. Okay, so again, I'll show you. So you push math button, and number 4, and 27, enter. Math 4. Pardon me? Nope. It's because 3 times 3 times 3 equals 27. Okay, so math 4 is the cubic root. Okay, of 27. So it's 3. So 3, which the first set it belongs to? Yeah, and as long as it's natural, it's automatically also a whole, an integer, also a rational, can be written as a fraction, and real. Okay, next guy, is there a repeat in this decimal?
Yes, there is.
Yes, there is. It does have a repeat. 4, 5, 4. So is that rational or irrational?
Rational.
Can be written as a fraction. Rational and real. Good. Okay.
Who knows what fraction?
This guy. Can it be written as, let's ask yourself. Does it either repeat or does it end? It ends. It terminates. It doesn't have dot, dot, dot after. It terminates. So if it terminates, can it be written as a fraction? Yes. So rational, real. Okay. What's 64 plus 36? Yeah. It is 100. Square root of 100 is 10. Okay. So that's all of them again. All of them except for irrational. And the very last one, what's 100 divided by 4? So square root of 25 is 5. So again, it's all of them excluding irrational. Yeah, very good. Okay, so turn the page. We have one more page to get through and it'll be quick. No, you do have homework today. Okay. All right, so first of all, we need to talk about these. This is a radical. We need to talk about the different names for things. Whenever you have a number in front of something, guys, whenever we have a number in front of something like 4x, what's that number called? A coefficient. Yeah, it's a coefficient. So this is the coefficient, the 4. Okay. This line here is the radical symbol. The house, I guess they call it sometimes. The radical symbol. The number underneath the radical symbol is called the radicand. The radicand. Radicand and you radicant. The radicand. And the little 3, we don't write it for square roots. We always assume it's a little 2 if it's not written, right? If we assume this index, it's called an index. Okay, we assume that number's a 2 if we don't see it written. And that's the index. That tells us if it's a square root, a cube root, a fourth root, a fifth root. I'm going to teach you how to punch that in. Yeah, I'll teach you that. Okay, so this chart, you need to memorize this, and I'm actually going to be maybe even testing you on it. Without your calculators. You're going to have to use your calculators for this unit, but I will promise you, if you know your perfect squares and cubes, you'll be a lot better at this math, this unit. Significantly better. And so I think I might even test you. Okay? Yeah. Okay, 0 squared and 0 cubed, that's kind of boring. And same with 1. 1 squared, 1 cubed is 1. Okay, let's do our perfect. Without your calculator, fill in as much as you possibly can. As much that you know. So these are the squares and these are the cubes. So 2 squared, 4. 3 squared, 9. 4 squared, 16. Fill as much as this that you can in. And then when you can't fill any more with your head, use your calculator to get the rest. Does everyone know how to cube on your calculator? Hat. Use the power of 3. Hat. The hat button. That hat button.
That's actually called correct.
The correct. I know, you always tell me that. Thanks. All right, so when we're squaring, we're going 5 times 5. 6 times 6. 7 times 7. Oops. Getting ahead of myself. 121, 144. Okay, so once you have your squares in, use your calculators and write down your cubes. You might even play some games too with this. You really need to memorize your squares and cubes. Up to 12. I promise you, you'll be so much faster if you do. Fast. Yeah, the cubes too. Yeah, it's not that hard. Trust me, I'll help you. It gets easier the more you get used to them. You're just not used to cubes. You're very used to squares. memorize a song. There's different things that can really help you. We watched a cool video. Oh, make a video and put it on YouTube. You should make a cubic song. Some things that can help you to memorize this. If you notice 7 cubed, 3, 4, 3, it adds to 7. 33 and 4 adds 7. 3 and 4 add to 7. 5, 12. This is related to binary code. So if you ever used to get your USB sticks, they're now really big. They used to always be like 512 gigabytes. Like that's the size they used to come in. Like that was like a standard 12 size. So if you know computer code, 512 might make sense to you.
Yeah.
729, 9. The first two numbers add to 9 and ends at 9, right? 7 and 2 add to 9. This one's easy. 1, 3, 3, 1. Notice a pattern. 1, 2, 1, 1, 3, 3, 1. 1728, always remember it's very similar to 729, except for it's 999 more.
Looks more like a year.
Different little things you can do to help memorize it. 25, 125, pretty easy. 4 cubed really cool. 64 is the cubic, the 4 cubed, but it's also 8 squared, so it's a cool number. Okay, so it's both a perfect square and a perfect cube. Okay, so you need to memorize these. Make sure they're down. All right, so let's talk about how to put this in your calculator. Okay, how would you type in cubic root of 27 then? Math, 4, 27, and then enter. So 4 is going to be, it's going to look like cubic root of x. I think it shows up as. Oh no, it just shows it as cubic root, right, with a bracket. Now some of you, you don't use brackets. You actually have to use the right arrow to get out of the square root on your calculator. So if you see an arrow flashing, some of you with better calculators, then you have to use the right arrow to get out. And I'll show you what that is if you need help. Okay, 5th root of 32. So this one's a little bit different. In this one, whenever our index is higher than 3, we actually have to type out our index first. So in our calculator, we're going to push 5. No. Close though. So 5. Math. Push the math button again. 5 math. Oops, 5 math. Which one do you think it is? Number 5. Oh, yes. It's next to me. Yeah, you're right, Joe. So number 5, which is x, or a star, as some call it. Okay, so we put the index first. So we have to, because of that x, we actually have to put the index first. So what this is saying is this is 5th root. Some of your calculators will actually insert it in nicely. It won't look as ugly as mine. And then 32, and enter. Okay, which was equal to 2. So 2 to the power of 5 is 32, or the 5th root of 32 is 5. All right, how would you type? See, notice the difference between cubic root of 5 and 3 root 5. Those are two different things, right? This is different, not the same as, yeah, you're multiplying the square root of 5 by 3. So it's 3 times the square root of 5 versus the cubic root of 5. Very different. So in your calculators, you actually just have to type 3, and it automatically will multiply if you go second x squared. 3, and then 5, and enter. So 5, enter. So notice the difference. If I wanted cubic root of 5, where would you go? Cubic root of 5. Math. 4, cubic root of 5. Very big difference. Right? This means 3 times square root of 5 versus the cubic root of 5. So what this means is 1.709975947 and so forth to the power of 3 would equal 5. So answer to the power of 3 equals 5. Okay, it stored the exact value in there. Okay. Now, whenever we type in fractions in our calculator and there's more than one thing on the numerator or denominator, what do you need? Brackets. Brackets. You actually have to wrap it in brackets. I always call them invisi brackets. I don't know, I make up words. They're there, you just can't see them. Okay? So, let's all type this in, because this is a tough one. Now, let me show you. So, your calculator might be a little different than mine. So, let's do this one button at a time together. So, start with your bracket to open up the numerator. 3 minus root 5. Now, some of you at this point, if yours opened up a bracket, listen very carefully, please. If yours opened like a bracket just like mine, then you're going to have to close that bracket. If it actually put the 5 underneath the square root, then you need to push the right arrow to get out of the square root. Do you know who you are? Okay? Oh. Okay. Oh. Okay. So for the rest of us, bracket, that closes the root 5. What else do I need? Before that, we need to finish wrapping the numerator. Okay, another bracket. Divided by? No. Open bracket. We have to wrap our denominator. 5 plus. So square root. At this point, I put in 3. If yours puts it underneath, then you push arrow to get out. The rest of us, because it's opened a bracket, we have to close that bracket. And close the bracket for the wrapping of the denominator. You should have that answer. Okay, so if you don't have 0.11 something, then you typed it in wrong. Okay, so I don't know if I want to write out, do you want me to write out all these instructions, what I typed in? Or are you good? Okay, so your homework today is 2 things, okay? You'll notice there's a worksheet on the next page. So that's just going to be checking off which, 0.3 repeating, well, it's a decimal, so it's not in natural or integer. It is irrational, it is real. I need to check. The answers are on the next page.
You do realize those markers don't actually have meaning.
Yes. Okay, so that's your worksheet. The answers are on the next page. So page 53 in your workbook, and then page 211 right there. So it's really going to be just classifying numbers, getting used to those definitions, okay, and typing things in. Yeah, 211, these numbers, and the worksheet on page 53. It's not that bad. I would do the worksheet first, but it's your call. Okay, the worksheet's right there. It's already open. You may as well get it started. And the answers are on the next page. So if you flip the page over, page 54 in your workbook, the answers are there. Okay, it shows you what they're expecting.
What about